Okay, so it's the weekend and I'm down at the shop working on the Cobra. So this weekend I'm working on mounting my fuse module or my relay module that I'm going to use to distribute all the power throughout the car. And I need to come up with some mounting to be able to install this thing and actually start landing wires permanently. So this is what I've chose to use. I see a lot of builds where people use standard automotive relays like this big monster 50 amp relay here. This one's a weatherproof type that takes like a GM 630 Metropack or whatever type connector on the bottom, so it's quite large. In fact, I don't want to have a row of 20 of these things behind the dash, so I've consolidated into this. So what it does is it provides the fused outputs. These are mini AT fuses, and it has a single J case fuse. This is a 60 amp J case that's in there now, and it has a threaded stud back here where my finger is that would attach like a single 6 or 8 gauge wire. Depends on how big you fuse this. I believe 60 or 70 is the max for this unit. So the idea is all your inputs, this is the input side of the module, is super low current. So I'm only going to run 22 gauge wire for this stuff. So that's going to go to my switches for my high low beam, my park lamps, my turn signals, the stoplight circuit. So all those inputs that are going to come from like the brake switch and the turn signal switch and the switches in the center of the dash are going to terminate here with little tiny wire. The output loads go here and then they're fused. This large relay provides like the key on power functions. So some of these circuits down here actually are connected to this. So when you go to key on but not run, some of these circuits are powered through this and then fused individually. And then there's some accessory relays in here. I'm going to use one for the horn, this one back here that says negative trigger on it. I'm going to use that for the horn, and through the cruise control circuit because it triggers with a negative signal, not power. And then these small relays over here control the outputs to the turn signals and the tail lights. And these two little relays back here that you don't actually wire up to anything, they do the sequencing for the hazards and the brake lamp and turn signal lamp integration. So you don't have a separate sequencing module like the boat trailer module. So it eliminates all that junk and you don't have to wire it, and you just have your inputs come in here and your outputs come out here. Sounds all well and good, but where are you going to put this silly thing? So what I wanted to have is when you open the right door, passenger door to the car, and you look up and contort your neck under there, I wanted this to fit between the door hinge and the back of the glove box, because I still have a glove box, but I needed something sturdy enough to support this so you could yank a fuse in and out. So what I built is this. So this bracket that I designed last night and then welded up today will allow me to mount the fuse module to something rigid enough. So this is going to get riveted to the 2x2 tube behind the dash. I'll go over to the car in a second, show what it looks like. And then that would allow it to kind of be at floating, kind of flush with the bottom of the dash. It is a really narrow space, so the width of this thing really can't be much narrow. So you'll see when I put this in there, this isn't much bigger than this, okay? I did make it from stainless. I'm normally really weight conscious, but I needed to be able to insert and pull a fuse out of this and it be rigid enough, and you'll see what I mean. So I'm going to go ahead and throw it on the scale since everybody gets upset when I do that. So I got the trusty scale over here. And so the relay module itself, here's the lid and all the screws and everything that holds it together. The relay module itself weighs 1 pound, 1.1 ounces. So it's not terribly heavy, but grand scheme of things, it cleans up a lot of junk behind the dash. Just for reference, if we wanted to be, this regular automotive relay weighs 1.5 ounces, but the reality is you need the plug and the assurance connector and the terminals and all that junk. So by the time you put all that stuff together, you're 2.3 ounces a piece. So they start to add up quick. All right, so let's go ahead and look at the bracket. So the bracket I built, like I said, out of stainless, and then I put nut plates on the back. So these are regular MS, like military nut plates for aviation type applications. And so they provide, if I can show in here, they provide a little bit of floating. So that this is a floating nut plate. They do make non-floating nut plates, but this allows you to not have to be perfect. Granted, I used a machine that could hold a few thousands tolerance to do it, but you don't have to. The other idea that I had is once this is mounted within here, okay, I'll screw it in a moment, the wires that come out of here need to go somewhere. I just have this clamp here temporary, so I built a little bracket to hold the wire harness as it comes out of here, and then go around the corner and it'll go into this other clamp potentially. Or I might use that clamp for the high current cable. So the high current cable will come off the stud, go straight out the side of the box here, through this hole that'll accept the grommet, and then bend around and perhaps go through here. I'm going to use the real high flex, high strand count wire from like Quick Car to do that for like the number 6 or 8. I haven't quite decided what I'm going to run yet. So the bracket that mounts it all, and to be fair, I'll include the 2 little screws. It weighs, oh, got to turn the scale back on, sorry, the automatic off got me. All right, so this bracket, which is heavier than I'd like it to be, but not so bad, and with the clamps and all the screws, and we'll include the other fasteners, weighs about 10.2 ounces. I probably could have gone lighter, I probably could have gone aluminum, but I have a feeling that you're going to push and pull on this a lot, and it's going to get abused, and the relay module there is bouncing on it when you drive the car. And in this case, I opted to go with a steel bracket instead of aluminum. So I'll go over to the car and restart the video and talk about where it goes. Okay, so here is a look at the carbon dash with the glove box in it, like the anniversary dash. And I want this thing, it's on the floor obviously, I want this to fit right in this area here, okay? And I know it doesn't look like it fits, but it does. It clears the glove box by like 1/4 of an inch. And in fact, where this corner here is cut off, because that's also the shape of the relay module, that clearance is needed to clear this corner over here. Okay, so let's go back to the car. Okay, so this is where it's going to live in the car. So here's the door hinge, right? I'm sure most people are familiar with that by now. And this is the bulkhead panel that I previously made with the quick connect in it. So the cables are going to run through this slot down here. They're going to run up here, up in this area here where there is not a ton of room, but again, I'm running a lot of small wire, through this quick connect, and then back out into the engine compartment for that stuff. And then the stuff that stays inside the car will go the other way. The high current cable will come around the corner and go into here. And I'm not quite sure if I'm going to go out here yet. I actually made a place for it to go out of here, but I don't think I'm going to do that. I may go out here because I have a firewall forward in the car. So this space right here is actually hanging over the engine compartment. So I may go out that way through a grommet or a fitting and then go down to the starter. So I might get my high current power from the starter solenoid, which, you know, plenty of people would tell you not to do. But General Motors has made millions of pickup trucks with that exact arrangement, and you've probably driven one and they work just fine. So that's what I'm doing. So that's kind of the basics. I'll go ahead and put this in there so you can see what it looks like, and then you can get a feel for that. Okay, so there's the unit installed to give you some idea what it would look like. The glove box ends up basically right here. I mean, it barely fits, but you know what? Barely is okay. And this isn't riveted in, I just have a clamp. You can see like almost, honestly, a furniture clamp holding this thing. So that way I could get a feel for it. But I think that this is going to do exactly what I want it to do. So I'll keep these wires here tight by putting them into a rubber dip clamp and going around this corner into here and then going back into the dash area. And then these wires, well, I know it looks super cramped. I'm running a lot of small gauge in this car. The Mill MS, the M22759 wire, which is substantially smaller than Crummy PVC wire. And so I'll be running out this slot, which I'll do a better job of deburring before I actually put the wires through it. And I'll probably either Kapton tape them and lace them, the ones that are coming out of this, so that they don't move around and rub on anything. And then they'll come out through here and come out right through here into the engine compartment. So I'm hoping that that kind of solves all of my problems, and my wire run inside the car ends up being this long. And then this wire run that goes to my centrally mounted switches, all my switches are going to be in the center of the carbon anniversary dash. All that can then be 22 gauge wire. So the diameter of my harness coming back, I calculated that at about 275, 300 thousandths, so like 5/16 basically. The size of a, well, big brake line. This car has 3/16 line, but some cars have, or some trucks and stuff have that big size brake line. So that would be equivalent. Or a plastic fuel tube. Plastic fuel tube's 5/16 on a lot of Ford cars. So like a Mustang would have a 5/16 return line fitting. So all my wire bundle from the center of the dash should be just that small. So that would free up. So I'll have basically nothing in here. I'll have all this room to do my heat box, which, you know, as you guys know, is not much room. I have a part of it sticking out into the engine compartment. I have a sample firewall here. Let me grab it. So here's a piece of sample firewall. You'll probably see more of that in the future that has a heater core assembly that I designed to be 3D printed. That'll be partially in the engine compartment, partially back here, and then I'll have to design a flapper door and all that because I want defrost and I want flip box heat and I want a glove box. So I know that you would commonly be told you can't do that, but you know what? Can't is a choice. right? You can choose to make it work. It just depends on how much time you want to waste on it. And that's pretty much it for this update. And if anybody has any questions, let me know.